All right, I'll give you about 30 more seconds to try to get in there. Again, the link, just because I love being ridiculous, the link, the direct link to Pear Deck is in the public chat. It looks like 6 of you are in there, and then probably the 7th is just getting there. Fabulous. All right. I have 7 people in there. Okay. Here we go. Let's start. So, oh, that's right, I can't do that. I'll do that in the next thing. So what is a limit and how do we determine them? Finding limits graphically and numerically is what we're looking at today. So again, we're learning to estimate limits graphically and numerically. Be very careful about that terminology. We're not finding, I know I'm saying finding limits, but really we're estimating limits graphically and numerically. Ooh, excuse me. We'll be successful when we can determine the behavior, excuse me again, a function using limits. I don't think I need to talk about Schoology as much because we're already doing everything in Schoology. If you have questions about what's on Schoology or how things are set up, let me know. But I think I have everything in there right now. Okay, here's f of x. What's a good estimation of f of 1? And why is it an estimation? Why not just f of 1? So here's what I'm going to do is I'm going to give you, thank you, Greta. You have 2 minutes to think and find out why am I asking those 3 questions and what do you think your answers are. So please start typing and or writing or whatever you can do on this slide. Go. You got, I don't see that. 2 minutes. About 20 seconds there, folks. All right. So I'm going to give you a 5-second countdown and then I'm going to pause you. 5, 4, 3, 2, 1. Boop. All right, let's see. F of 1 means you're plugging in that 1. So the denominator is automatically going to equal 0. So we can't get an actual answer, but rather an estimate. Fair. Is it because there's a limit at f of 1, like a whole? Okay. An estimation would be a quicker way to generally solve a problem in a shorter amount of time, especially when it's complex. It could be a whole. Very nice. An estimation gives you a more general look at it. I don't know. Okay. Plugging in 1 down there. They were still typing while we're going. That's fair. Okay. Cool. So to address some of those things, yes, there is in fact a hole there. And we know there's a hole because when you plug in 1, you get 0 over 0, right? And since you get 0 over 0, that's indeterminate, and that almost always is a hole. Yeah, almost always is a hole. For pretty much everything that we do, it's a hole. So we can plug it in, but we get the hole. And knowing it's indeterminate means that there probably is another way to get the limit. That's not always the case, and we'll see that later. But often, if you get 0 over 0, it's indeterminate. There's something else we can do to figure out what the limit might actually be. I think this one actually does have a limit, but we haven't talked about what, I wasn't asking for that just yet, but I love that. Thank you for the foreshadowing there, Greta. But again, estimation, we talked about that. Good. So it is helpful to have estimation maybe from both sides, or to look at a graph in order to estimate that. Those are two different ways that we could estimate what that value should be. And that, again, is just the idea of a limit. It's estimating what the value should be, or what value it's approaching. We use both those concepts kind of interchangeably. Okay, you get to doodle some more. So you have 2 minutes to answer, try to find the value of 1 through 3, and then try to find the limits for 4, 5, and 6. So again, I'm gonna give you 2 minutes to try to do the best you can. This is trying to recap and trying to reactivate knowledge that we worked on last year. Okay, so you have 2 minutes, go. That should just be starred. We can deal with that later. Oh, that's right. I can do this in the meantime. About 10, 15 seconds left there, folks. Who's not in? Oh, there we are. All right. So I have your responses open up on my window. So we're just going to try and talk through a couple of them to see what we get. There's some interesting things that we have. I appreciate the color coding and the using of does not exist on several of them. Fabulous. So let's look at 1, 2, 3. So these ones, we're literally just going to plug in the number and see what it is. That's what function notation tells us. It says the function f at x equals 4. Or the function f when the input is 4. What is that value? So f of 4 does not exist. So the f of 4 does not exist. It just doesn't. When we draw that line straight up, nothing, never hits the function because there happens to be a hole right there. F of 2, well, if we go to 2, the input is 2, my output is 2. So I have does not exist for number 1, I have 2 for number 2, And for number 3, if I go up until I hit the function, bam, it is in fact 2. So I should have does not exist 2, 2. Now these are going to be, for the most part, at odds with the limits. So looking at 4, the limit as x approaches 4. So that's saying not what is f at 4, but what value is it approaching? Well, if we look at 4, we start a little below it and a little above it and trace. I'm using my fingers to trace. It just looks weird because I'm on my other screen. If you put a finger on each side of it and trace it, like Benny and Bert the Bug, and they try to go to the spot, they both end at they are both approaching the same value. So the limit as x approaches 4 of f of x does exist, and it's 2. Even though that's not the function value, that's okay. Limits are about what are we approaching. Whether we get there or not is insignificant. It's about what value are we approaching. Well, so the limit as x approaches 2, well, from one side, they're approaching 2. From the other side, they're approaching 3. They're not approaching the same value. So that value does not exist because limits can only have one value, okay? And if there's more than one possibility, the limit does not exist. Looking at x equals 1, well, you go from one side and from the other side, you're going to the same value. It looks like you're approaching the same value. Therefore, the limit exists and that value looks to be 1. So recapping, the f of 4 or f of a means what is the value at that point, whether it exists or doesn't. The limit as x approaches a of f of x is saying what value does it look like it's approaching, okay? Now we just did a bunch of estimation here. We estimated using the graph. So again, all of these are estimations of what the limit should be. There's other ways we could do it if we actually want to find out what the limit is. Speaking of which, here are 4 more limits for you. So let's see, we get done at 55 and it's 44. So I'm going to give you about 5 minutes to work on all 4 of these. If you don't get through all of them, that's okay. But start anywhere. It doesn't matter where you start, and just start working through them. As you're working through them, I'm going to set a 5-minute timer for myself so I know when to kick you off. But just start doodling, writing. Tell me estimate what the limit is, or tell me it doesn't exist. And then tell me which method you're using. Are you using a graphical method or a numerical method? Numerical is just plugging in numbers nearby. Graphical is literally graphing it and looking at the graph really close to see what it looks like. All righty? All right, here's 5 minutes on the timer. Go! Remember, folks, numerically isn't just plugging the number in, it's plugging in numbers nearby. So if you want to numerically do that, plug in numbers like, I don't know, negative 0.5 and positive 0.5. And then maybe pick numbers even closer to 0. Plugging in 0 is an important thing right away because you want to have an idea of what's going on. If it's not indeterminate, it's not even worth going, like doing much more. If it's indeterminate, boom, it's not going to exist in the first place. But then checking the other two things might help you understand like what kind of, or for why does it not exist. Remember to plug in numbers nearby and we'll look at stuff. I'm seeing some interesting things from y'all. Again, once you think you know what the limit is, whether it exists or not, tell me what method you use. Take a moment to write that on there. You've got about another minute and a half or so, just under that. I'll have that lamp right there. Like, I should respond right away. Oh, maybe I'll just build. No, it'd be nice to just throw that bad boy on there. All right. Let's discuss and debrief. So I see a lot of interesting results. My favorite one to talk about is gonna be number 4, but I'm seeing a lot of good justification and things as we're going through stuff. Cool. Let me show you what the answer should be, and we'll talk about it from there. All right. Number 1, the limit is 2. 2, 3, and 4 don't exist. Let's discuss that. Well, for each of these, when you plug in 0, you're either going to get does not exist or indeterminate. 1 and 2 are both indeterminate, so you have to do something more to find out that, in fact, it's 2 and does not exist. And 4 is just kind of a weird thing, because when you plug in 0, you get 1 over 0. What's cosine of 1 over 0? Which the more you think about it, and if you kind of process it a little bit, it'll make more sense of why it is what it is. But 1, again, if you look at the graph, you'll see that it's approaching the value of 2. So we can estimate that limit to be 2. Number 2, or again, number 1, you could also plug in numbers nearby to see what it is. With the square root, I doubt a lot of you did that. I would bet that most of you probably just like, no, I'm just going to graph that and go that way. And that's fine. 2, numerically or graphically, I think this one's about the same. When you notice when you plug in numbers or look at the negative numbers, you're getting values that are -1. But when you plug in positive numbers, you get +1. Those aren't going to the same thing, so a limit doesn't exist. Number 3, well, if you plug in numbers on either side of 0, it's going off to positive infinity. So if you had infinity as your answer, that's also a correct answer. So like to make my answer even better, I would say does not exist, but goes towards positive infinity. Would be a nice thing to put in there. I didn't put it in there, but that gives me an opportunity to discuss it real quick. Number 4 is friggin' weird. Because what's happening in number 4 is numerically it seems weird. Because as you plug in different numbers, you get different things. You're not really sure what's going on. When you graph that one, you see that cosine as it gets closer in, starts oscillating, going back and forth, faster and faster and faster until it's going like this. And if it's going like this, how can you determine what the limit is? And the closer you get to 0, the faster it oscillates. If you graphed it on Desmos and zoomed in, it's basically just a block of function because you can't see anything. You can still evaluate any value up to 0, but there's no one value it's approaching. So the limit does not exist there. Ba-da-ba! Try to foreshadow this by typing it in there. The limit does not exist. But when is Katie right? Well, here's 3 conditions, 3 different times generally that the limit does not exist. Number 1, the left and right limits don't agree, which we saw with number 2. The second thing, the limit goes to infinity, which we saw with number 3, because if it goes to infinity, there's nothing capping it or bounding it or anything, so there's no limit. Or number 3, the function oscillates quickly between 2 values, like number 4. Those are 3 of the places where you'll see stuff like that. Okay, to wrap it up, and hopefully have a little time to do some other things real quick, here's your practice. Read section 1.2, and there are the problems. So 2, 3, 5, 8, 9, 11 through 20, 37, and 42 through 46. All right, these aren't due by the next day of class. We're going to spend another day working on some 1.1.2 stuff. But you should start working. You should get going on it today. This afternoon, if you have questions, again, message and post in Discord if you have questions, or email me if you're not using Discord for some reason. I just got an email that someone's like, I'm not going to use Discord. Okay, it's fine. It's just an extra opportunity for us all to collaborate. And it's nice to be able to collaborate. So there's that. Any last minute questions before I end the meeting? Cool beans. There's your assignment. Work on that, and we'll see you later, folks.